right? Not only could a steam engine do the work of 1,000 men or women, but it could do it with the power of 10,000 horses. And that's why. So if you look at all the data afterwards, you have actually hyper exponential growth. Yes?
Because one of the things that you seem to be missing is when we went from being a population that wandered around and hunted and became farmers, that's when the real growth took place. That was, I think, a bigger. That's not the case.
Nope. If you look at the data, it's not supported.
That was always my understanding.
That was an important event, right? It was from the race dying out to the race going on, right? So in that case, it was important. But in terms of impact, right, that was actually measurable at a global scale. The steam engine was the impact.
You're dismissing things like the Roman Empire and all these ancient civilizations that had massive technologies and efficiencies. They built
If you look at the data, hey, I'm not making this up, right? You just look at the data. You look at population growth. You look at life expectancy and how it evolved. You look at income, estimated income per capita. It's pretty much linear, right? Wiggle here and there. It's not there.
So
Yeah.
you want to run blockchain on a steam engine?
Yeah, I mean, you could be kind of hard, but I haven't really thought about that. But good question. I mean,
I'm thinking Xeon processors better.
yeah, maybe. But the reason why I'm asking this sounds like a little detour. The reason why I brought this up is because, again, it did not only automate, but it exponentiated. And that is the key. So automation by itself is great, but exponentiation is the kicker. Okay? So since that time, there has not been any other technology that has really done that. Okay? Now come blockchain. What does blockchain do? Blockchain removes a physiological limit that human beings have, which is called the Dunbar limit. The Dunbar limit is the number of stable social relationships that a single human being can maintain. That's between, on the studies, and the individual 75 to 200. Why is that important? Because every organizational structure you see around you, governments, municipalities, banks, insurance companies, all have a centralized hierarchical structure. Why is that? Because when you have a limit and you put more people together that is more than the limit, than the Dunbar limit, you somehow need to figure out a way how to trust one another. Right? Which means you then say, hey, I trust him. Hey, I trust him too. Hey, I trust him too. Right? And then you start to delegate trust. You create trust intermediaries. Guilds. Right? Yes?
When I dial up for Amazon and I buy something, there's a lot of trust there. We're exchanging money, they're sending goods.
Yeah.
So basically the public key solves that on the internet. The issue of trust and for communicating information. I don't know, not exactly sure
No.
where the trust issue really comes in.
So the trust issue is that how do you know that I cannot cheat you? Right? Amazon can take the money and then not send it. Then you need an arbiter. Right? You need a third party. Right? With blockchain you don't. Because you can't cheat. Right? So if we're doing a transaction on a blockchain, then you will have to jump through a whole lot of hoops, right? To make sure that the transaction is valid. And then once it's part of the blockchain, you can't change it, or it's very, very hard to change, exponentially hard, in fact. And therefore, I can always prove that yes, I paid you that money in exchange for these goods, right? And if you're smart, then you don't get the goods. The money was in an escrow account, and then it's reverted unless you say yes, I actually did it. Like you countersign the receipt, right? So the really interesting thing is when you have this removal of the trust barrier, right? You can now, as long as we do exchange information and do value exchanges on the blockchain, I can trust every single one of you, even though I don't know you. In fact, I don't even need to know you, right? And not only that, I can do it with every single device, right, that interacts with me on the blockchain, right? And therefore, it's not only 7 billion people, but 100 billion, a trillion, 2 trillion devices, right? So that's true exponentiation, which means we can now are in a position to not have to rely on third-party trust providers, such as banks, insurance companies, governments, and so forth, right? You can actually start to create self-sovereign organizations that do not have a central entity, central organizing force. Might be have an organizing principle, but not necessarily someone who says you've got to do this. Do that, right? And therefore, entirely new organizational structures are possible. But only for companies, quote unquote companies. The company is again, that whole concept is changing, right? Concept of society, what is a society, is therefore changing, right? So therefore, we are we were the steam engine like 20 years after it was invented, 10 years after it was invented. Right? We're just seeing the promise. We're just figuring out, oh wow, if I put that engine there and I put like a whole bunch of like carts behind it, I can move a whole lot of goods back and forth. I can move people back and forth. Right? That's when the train came about, and everybody was like, whoa, you get killed. It's really bad. Like all kind of bad stuff can happen. It's the same thing that we have right now. But this promise of being able to remove those organizational barriers and come up with exponentially large organizations where every participant can trust the other one without having to know them, right? And without having to have a personal relationship with them. And that is what that's the promise, and that's why I'm personally fascinated with that, because we can, yes.
Well, so how does that, the exponentiation you talked about, how does that play with the continuing research into like quantum computing, right? So right now there's sort of an even playing field around the computation of blockchain cryptography. But what happens when a particular party in the network becomes that much quicker than everyone else and can sort of do an end run around everyone else trying to calculate equally quickly the next number? When does that deteriorate the trust in anybody?
In principle, yes. That's why Quantum Ledger did an ICO.
So I think that maybe take it one step upward, so to explain the question itself in terms of.
Yeah. So let me talk about how blockchain actually works, right? A little bit. So very high level. So so you and I, we do a transaction. I give you a crypto unit, Bitcoin, Ether, whatever that your unit of choice, and that's recorded as a transaction. It's validated, and then it's combined with other transactions into what's called a block, right? And now the magic happens. The magic is that I am putting this block together and cryptographically link it to the previous block which is a block of validated transactions, right? And then I'm sending it around to everybody else who's participating in the network. In Bitcoin, in Ethereum, they're called miners because they're doing a particular task, which is they're doing a lot of computations really, really fast. Let's just say that there is a cryptographic riddle that these nodes need to solve. And in the case of Bitcoin and Ethereum, it takes a lot of compute power to solve this riddle. Whoever solves this riddle first, right? And that's one of the magic. They win and they get rewarded. So you have to put upfront energy costs or money, right, for the promise of being the first and then being rewarded with cryptocurrency that is worth, Bitcoin is what, 2,800 right now, something like that, huh?
Sorry.
Or 2,400. Goes up and down a couple hundred every day, right? So that is a big promise. So you actually have married economic incentives at the atomistic level with technology. And only if everybody else in the network agrees to says, yes, you actually solved that cryptographic riddle. Only when everybody else, the majority of them at least, have said, yes, what you just proved to us, right, is true. Only then will this block be part of the blockchain forever.
So any engineer will say, how are you handling an infinite number of transactions that are stored in an infinite number of servers in an infinitesimally small piece of time? Because that, I've always been puzzled about blockchain. Because blockchain purports to essentially be scalable in terms of number of transactions.
Mm-hmm.
And it's also distributed in a very large number of miners. And then you're reconciling it for a majority of the miners very quickly because that's the value of the transaction. It's nearly instantaneous. Can you explain how that puzzle is resolved? How do you do?
Andreas, before we answer, just with a very diverse crowd, from technical people to extremely technical people to non-technical people at all.
Right.
So let's try to give the answers so everyone will understand. So from the concept of the blockchain, that why they need the nodes, or what is that and what is the block that you explain now in terms of the cost of the mining, etc.
Right.
And in fact,
So again, effectively, what you're trying to, the trust that I talked about resides no longer with a third party, but resides actually in code. It's the protocol, the blockchain protocol, that holds that, because every node runs the same protocol, right? You can trust that, well, if they all run the same code, they'll come up with the same answer, right? So that is why, and once they agree that, yep, your result is correct, your result is correct, your result is correct, because you have cryptographically linked it, right? You have solved the cryptographic riddle, and you have created this cryptographic link that is virtually unbreakable. It's exponentially hard to break. You can then now trust in what the majorities of these computers said is the truth, right? Now you ask about how can this scale, right? Well, the answer to that is, well, how does Facebook scale? How does LinkedIn scale? Right?
Servers.
Exactly. So what you do,
Faster connections.
faster connections, more
They
servers.
scale through parallel processing, but you specifically don't do that.
Actually, you can. You do. So one of the key things is that you can say, well, so when we're doing transactions here in Los Angeles, right? Does that have to be validated by nodes that are over in China?
That's the premise. It's a single ledger.
Well, you don't need to validate, you just need enough nodes, right, to do the validation, right, that it's hard to manipulate the majority of those nodes.
Aren't you basically saying that one blockchain connects to another? It's a
That is right.
sequence of chains.
It's
So-
actually, you run them in parallel. You can either logically run them
So you've got
in
clusters of
parallel.
blockchains that then get linked up, is that what's going on?
That is true, yeah. You can make blockchains
I mean, I don't mean to get into the
No,
weeds.
but you can make blockchains interoperable, right? The key thing is that each blockchain needs to have a large enough set of nodes that it's hard to subvert them. That's the key thing. So just like what? So I run 10,000 servers. I run 10,000 blockchains. What's the big deal? Compute is cheap, storage is cheap. Who cares?
So allow me to ask a couple of
Sure.
simple questions. What is the node that you keep talking about?
The node is a computer, and the computer who runs that blockchain protocol, be it Bitcoin, Ethereum, or any other protocol, and is linked to all the other nodes in the blockchain network.
So we keep hearing everywhere blockchain with Ethereum and Bitcoin. Is that only for that?
No, it's you use it for any blockchain or distributed ledger technology system that fulfills a couple of criteria. That has a consensus protocol, that has validation, and that has cryptography built in order to make sure that the system is secure and participants can't cheat.
Would it be heresy to say that it's basically just another database structure?
It's a very inefficient database structure, right? Blockchain is not a good database. That's not. It's a really bad one, actually, right? It's a ledger, right? And a ledger is not really good for storing. It's storing for particular pieces of information, right? That's important. It's about when we exchange value, what do we need to store, right? So the idea of storing, like the latest Star Wars movie on a blockchain, is by and large a pretty bad idea, right? There are architectures, blockchain architectures, that will allow you to do that, and they're actually very interesting, and we're working on some of them. But that gets really so far. Let's say that the issue of scalability of blockchain, so you can do 1 trillion transactions an hour, do a zettabyte of data a day, have 1 billion concurrent users and 100 billion concurrent devices is possible.
And at the end of it, you have a consistent copy of all these transactions distributed worldwide. That doesn't make any sense.
No, you don't need to.
Okay, that's what I'm trying to understand.
Right. You
How do
don't
you do-
need to. You only need to have the let's put it this way. There are certain types of blockchains, such as Bitcoin, where you actually need the entire blockchain, right? And that has to do with the way that the blockchain is structured. That's how the protocol is structured. Because it only counts what hasn't been spent, right? What hasn't been given to someone else. So that in order to have the entire genealogy, right, of a transaction, because I could have some Bitcoin that was mined back in 2009 and that I'm spending it now, right? Which means if I don't have that transaction that I can validate where it came from back in 2009, you can validate that transaction.
My concern is valid for Bitcoin, but not valid for something like Ethereum.
For other chains, you can come up with schemes that allow you to lighten the load, as I like to say. You can call it. There are compression schemes, like pictures that are really large. You can compress them down. There's a similar approach that you can do with blockchains, where you can compress blocks down and only keep sort of like a fingerprint of them. And as long as you know where the actual thing is stored, if you need that one, you can look it up. So that's a way. Yes.
Could you give a scenario from whatever the equivalent is to collecting premium up to promise to pay and then distribution of funds, and then what you do with your digital profit or whatever. Would you give a scenario that takes it through the whole process of what it would be like?
Yes, yes, very good, very good, very good, very good question. So, before I actually answer that, I need to take one step back and explain that there are constructs on a blockchain that are called smart contracts. Smart contracts are nothing but computer code, right? That is run on every single blockchain computer that runs the protocol. And every single computer executes, again, the same code. Not only the protocol, but the code in the smart contract. And that code can contain business rules, for example, for adjudication, right? They can have the terms and conditions of your policy, right? At least the functional part. And the nice thing about it is because every single computer runs the same computer program. And because the digital fingerprint of this computer program has been put on the blockchain, I can prove that every single one runs the same, and if they come up with a different answer, they cheated, right? So this is what's called proof of execution. And that is important because once you have proof of execution, I can now do a whole lot of complex business logic, right, on a blockchain. And with Bitcoin, I can only move Bitcoin from A to B. That's it, pretty much, right? Complex business logic really can't be executed. With Ethereum, because they have the concept of a smart contract, right? Because they have a virtual machine that is actually sitting on top of the blockchain. You can execute complex business logic, which is required for insurance scenarios, right? So for example, I can write a smart contract that says, hey, this is a life annuity product, right? And it has these rules, right? And I can send a command, right, to the smart contract and say, hey, for Joe, right, and his wife, for this amount of money with this premium, initiate a policy, right, as a smart contract. So then I can have that policy then becomes part of the blockchain. It's recorded. Conflict resolution can happen. And now I can directly pay the insurance company without having to go through a bank. So I can send you the premium payment. I just got my payment notice from my life insurance company. Please send this check to blah 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 and write everything on it, including terrible. In this case, I can just simply have I just get a notification either as an email or in an app that says please pay, right? And you click on pay and it's done.
Can I stop you there?
Yeah.
So if you pay, you have to transfer your funds what's already in.
Or you could pre-fund, yes.
But to your point, it's volatile. So if it goes up $200 or down $200, goes down $200 at the time I pay, I've actually just spent $200 more for something. Is that how it works? Because I'm losing my value.
No. That would only be if you stick with the concept of Ether, yes, right? But for example, you can define, because now you have this concept of smart contracts. I can define, let's say, the AXA token on a blockchain.
We don't know what, most of the people here don't know what Ether is or AXA token.
Right. So Ether is the base currency for Ethereum. Bitcoin is the base currency for Bitcoin, and it is used to compensate the computer nodes that are maintaining the blockchain, that are running the blockchain, that are validating the blocks and doing all the work, right? You need that because it has to be intrinsic there. If you have a public blockchain that is run through incentives, you need some form of compensation. So you have this built-in currency, like the US dollar, to be able to compensate the people who run the computers and expend money, right? They pay upfront, right? And they hope that if they generate the blocks and they're being a good citizen for the ecosystem, that they're getting rewarded by the protocol.
So the AXA token, you don't lose any money. You pay.
With the AXA token, you have the organization that defines these tokens are now not directly linked to Ether anymore. Okay, they are just defined as code in these smart contracts. And you can create any number of them. You can say 1 billion, and you can say, one AXA token is equivalent to $1, right? And that's it, right? You determine the value, right? So AXA could determine what the value is. It says 1 token is $1, or 1 token is 1 cent. Doesn't really matter, right? You just need to have a statement of value imprinted, right? And be part of the smart contract. And then everybody can check it and say, oh, okay, that's what it is.
So just moving back to a bit more of a high level, the steam engine enabled a customer to move from, let's say, San Francisco to New York in X amount of hours. The user experience there was a huge improvement in user experience. With blockchain, where is the improvement in user experience? How does it progress from there? Do we see anything happening?
That's a very good question. So, have you ever read like the reports from the first passengers on like trains? Right? It was cold. It was smelly. It was like ugh, right? So just like your Bitcoin wallet. Right, very often is, or it's the equivalent. It's the early. It's like the airplanes, right? Man, when you were up there at in the 1920s when commercial air travel started, when you were up like at 10,000 feet, you better had a nice thick coat on, right? It was not a great user experience.
If I can translate an answer for this question, like right now you're saying that we, in the current society, are maintaining relationships with credit card companies, with our banks that are holding our money for us.
Right.
Those relationships we need to do that, like monthly, you write a check, you have to remember to write a check to pay this person. If you don't, they can charge you interest for not even paying on time because they're acting on your behalf to settle your bills. They all go away.
But it's essentially very easy to automate all of these things. I mean, you can write code
Right.
which does transactions.
Does it, right? I mean, credit card is pretty much automated, right? I mean, there's but he was talking about the user experience of using that technology, right? So if you want to have the experience of being able to pay me, right, or to do a transaction between you and I, like a contract, right, without any intermediary, right, the experience is clunky, right? But we get a huge benefit. It's like you don't have to worry about a lawyer, you don't have to worry about a bank, you don't have to worry about an insurance company, right? All that other headache, right? So you get that freedom to make choices. Right?
So what would be the incentive? So
It seems like the user experience hasn't really changed. I mean, it's kind of similar to if you didn't care if someone got a hold of your financial details. Like if you didn't care at all, you're like just like we're open with everything that you have, then it would be the same user experience. It seems like. It seems like what the blockchain gives you is just a sense of knowing that the transaction
of trust, right? It's that it gives you freedom. It gives you freedom to that you and I do a transaction, right? Even though maybe someone else says, no, you can't do that. Well, we can still do it,